let's play a game. We have a well-defined objective and 2 minutes to reach it. We only have 3 rules, and the end result is a completely different way of coding. So welcome to Test-Driven Development, the game of unit testing. So in today's tutorial, I will demonstrate a basic test-driven development workflow, where the goal is an encryption function that hides secret messages. Now, in my case, I'm gonna go for a very simple encryption algorithm known as Caesars Cipher, where we take the letters of the English alphabet and we shift them 1 character to the right, in such way that A becomes B, B becomes C, and then lastly, Z becomes A. Now, the first question to ask is, can we even write such an algorithm in 2 minutes? Probably not. There are many components involved and things get extra stressful when the clock is ticking. So we will approach this with a classic divide and conquer strategy, where we take this very big task and we break it apart into much smaller tasks. We can then solve them 1 step at a time, or actually 2 minutes at a time. You will see what I mean shortly, but first, let's go over the rules. These are the rules of test-driven development, which is a set of programming principles aiming to create reliable, flexible, and very, very modular pieces of software. So rule number 1 is you may not write any production code unless you've written a failing unit test. Which means that we first define exactly what we are testing, we have this really nice objective, and then we make sure not to reach it. We fail on purpose. Then we move on with rule number 2. You may not write more of a unit test than is sufficient to fail. So there are plenty of ways in which we can fail, but our job is to do the bare minimum to make it happen. Now, before we go over the third and last rule, let's see those 2 in action with the help of an example. So let's say that our first objective is testing if we even have a message to encrypt. Now, for this, we will of course need a text editor or an IDE to perform our unit tests. In my case, I'm using Wayscript. Now, first things first, let's import a built-in Python library called unit test, and we will use it throughout this tutorial. Next, we will encapsulate all our future tests in a class called test encryption, or any other name. The naming part is entirely up to us. What is not up to us is that this class must inherit all the attributes and all the methods of another class, which we will simply fetch from the unit test library, and the name of this class is test case, with a capital T and a capital C. Now, if you are not sure how to work with classes or what is inheritance, I have 2 amazing tutorials on the topic. They are very simple, but very important. Now, within the body of this class, this is where we define all our tests. So for now, I'm just gonna leave a comment here, tests go here, and we will tackle this shortly. Now, at the very, very bottom, we will need 2 additional lines of code, which I'm sure many of you are familiar with. So if name equals main, with a bunch of underscores in between, of course, we will then run our unit test by calling unit test.main and an empty set of round brackets. Now, don't worry about it if you're not sure what if name equals main means. You can always leave me a comment below, but I am planning a dedicated tutorial just for this line of code. I'm going to simplify it, and it's going to be a really nice tutorial. Now, this syntax works great if we are dealing with a Python file, such as my Caesars Cipher.py. However, if you are using a notebook interface, such as Jupyter or Colab, you will need to replace those last 2 lines of code with the following command. And it's actually very similar, because we are still calling unit test.main. It's just that in here, we specify the argument vector, we specify the verbosity, as well as exit equals false. Now, you can copy this line of code from the description. I'm including it below. So once we have our basic infrastructure, we can move on with the actual tests. But how exactly does it work? Well, with each of our tests, we are aiming to evaluate a Boolean expression. Is there a message or not? Is it true or is it false? We call those types of expressions assertions, and luckily, we can easily get them directly from the unit test module. So let's go ahead and define our very first test by defining a new method. We will call this method test underscore input exists, where the first portion of the name must always be test underscore. Very important. But the last portion of the name is entirely up to us. Now, just like any other method, this method will take in the self parameter, which makes it a method. And then in the body is where we specify our assertions. Now, in the case of checking whether a piece of data exists or not, we can use the self.assert is not non-assertion in camel case. And as you may guess, this assertion will take in the message we'd like to encrypt. Now, we are yet to define this message, but that's okay. Because if you remember, our very first test must be a failing one. So we will just specify an arbitrary name of a message. We will call it self.myMessage. Cool, now let's save everything. Let me slightly zoom out just so we can see the results better, and let's run this piece of code. We will then pull out our terminal, which tells us that we have successfully failed our very first test. There you go, failed with one error. Now, I'm not sure if there's even a better way of failing this test than not defining my message to begin with. So in terms of rules number 1 and number 2, we are fine. But how about rule number 3? So the last rule to consider is you may not write more production code than is sufficient to pass the failing test. So the concept of bare minimum is back again, and the real question to ask is, what's the least we can do to fix our code? In our case, the least we can do is assign self_myMessage to some kind of value. And the way to do so is within a special method called setup with a capital U. Now, the name here is very important because unlike other classes where we initialize our attributes inside the init method, in the case of the test case class, we do this inside the setup method, okay? So we will just pass the self parameter here and we will assign self_myMessage. Well, I guess the minimum we could do is assign it to 0. And I know it's not a very informative message or probably not a message at all, but if we run this code, if we take a look at the terminal, we have successfully passed this test given this okay here. Now, the last question to ask is, did this process take us less than 2 minutes? Well, if we ignore all the time it took me to explain everything, all we have here is just 4 lines of code, so the answer is yes. Now we can finally move on with the rest of the tests, and we will of course speed things up a bit because we already know the rules. Our next objective is testing whether my message is a string. And for this we will of course need a brand new method. We will call it test_input_type. And in the case of evaluating data types, we will use the assertion of self_assert is instance, which takes in 2 arguments. The first argument would be the data we'd like to evaluate, so self.myMessage. And the last argument would be the desired data type of str or string. Hopefully I didn't block this long line of code with my head. Let's give it a run. And we see that we have failed one of our tests. And that's perfectly fine because this means that we comply with rule number 1 and rule number 2. 0 is indeed not a string. So what's the easiest way of fixing this? Well, how about if we will replace 0 with an empty string? That's pretty much the bare minimum. We will then save everything, we will rerun our code, and boom, now we have passed both our tests. So it seems that our input is fine, at least at this point of time. But how about the encryption algorithm itself? We haven't even defined it yet. So let's say that our next test will check if a function called encrypt returns some kind of an output. So what we will do is we will copy our very first test, the one that checks for the existence of certain data. We will then paste it right below. We will slightly refactor it. We will change the name to function returns something. And we will then wrap our self_myMessage attribute inside an encrypt function, which we are yet to define, of course. Let's save it. Let's run it. And we see that we are now dealing with 3 different tests and one of them fails because the name encrypt is not defined. So what would be the minimum we can do to fix it? Well, we'll just define it. So at the very top of our code, we will create a brand new function called encrypt, which takes in a message and returns 0. Now let's give everything a nice save. Let's see if it worked. And our third test is done. Next, we will test the length of our secret message. Now, since Caesars Cipher simply swaps one character with another, the length of our input should be a perfect match to the length of our output. Now, in order to test it, we will need some kind of a secret message. So let's go ahead and fill in banana inside our previously empty string, and we'll navigate below. We will then create a brand new method called test_len_io, as in the length of input and output. Now, in the case of evaluating two entities, we can use the self.assert equal assertion, which takes in two arguments. The first one would be the length of our input, self.myMessage, and the second one would be the length of our output. So encrypt self_myMessage. Beautiful. Let's run it. And surprise, surprise, the length of 0 is different from the length of banana. And actually, since 0 is an integer, it has no length at all. So what would be the easiest way of solving it? Let's go back to our code. Let's navigate to our production code. So what if we replace 0 with the message itself? It must have its own length. It's the same entity. So let's go ahead and save this code. Hopefully we were able to trick the terminal. Let's have a look. And beautiful! We have indeed tricked it. We are passing our tests. But the only problem is our secret message is not exactly a secret. We are not encrypting anything at this point of time. So let's make sure that our input is different from the output. Now for this, we will of course need an additional test. We will define it at the very bottom. We will call it test_different.io. Now we could probably once again use assert equal, but just for the sake of this tutorial, we will do something slightly different. We will use self_assert not in. Which also receives two arguments, and in fact, those are very similar arguments to the one above. So we'll just copy the input, we will specify it first, and we'll then copy the output, which we will specify second. So we are checking whether the input message is revealed within the output. And yeah, we can probably dispose of this extra closing bracket. Cool, let's save it, let's run it. And oh no! A banana, unexpectedly found in banana. This is shocking. Now, one way we can solve this is by replacing each of our string characters with its index value. Now, we've done something very similar in a recent list comprehension tutorial of mine. So if you haven't had a chance to check it out, please do. So what we'll do here is we will create a local variable called encrypted_message, and we will assign it to a list comprehension. Now we will begin with a very basic statement, and we will of course build it up. So char for char in message. Now since we would like to replace the original character with a different value, we will wrap our message inside an enumerate function, which now returns two iteration variables rather than one. So first, it returns the index value with IDX, and then it returns the character itself, in such way that the index of B is 0, the index of A is 1, and so on. Now, since we already have this beautiful IDX iteration variable handy, we will simply replace the original character with it. There you go, IDX. Then we will of course print our encrypted message right below, just so we have a nice idea of what's going on there, and we will then return it instead of the message. Now let's save it, let's give it a run, hopefully it worked. And yep, it worked! We are passing our test, we are dealing with two different entities now. But what exactly is this? What am I looking at? How come our encrypted message is now a list? It's supposed to be a string. So let's make sure we are testing our output type and not just the input type. So we'll just copy our existing test. We don't need to write a new one. We'll just slightly refactor it. We'll paste it below. Now input becomes output, and then self_myMessage becomes encrypt, self_myMessage, and we are still interested in a string. So now let's run it. Okay, that's more like it. We are failing because a list is indeed not a string. So let's go back to our code and let's fix it. Now, if you watched my list comprehension tutorial, you already know how to do this. We will simply wrap our list comprehension in a join method following an empty string, which will of course join our entire list into a string. Yeah, so now we can finally save it. We can have a look at the results. And oh no, we are still failing because it seems that we are dealing with integers rather than strings. So let's see what's going on here. Well, it kind of makes sense because indices are not strings, they're integers. So let's simply wrap idx in a string function, and this one should fix it, right? Let's run everything. And beautiful! We are now successfully passing test number 6. And in the very last test, we will check whether our algorithm actually shifts the secret message one character at a time, which pretty much brings us back to the very first task we have divided and almost conquered. So let's go ahead and define a new method called test underscore shifted cipher. And before we decide which assertions to use here, we will need to find a way of fetching the entire English alphabet into our code. Now, since we don't have the time to type it all, we will simply import it from the string module. So at the very top of our code, we will first import string, and then within the body of our recent test, we will set string.ascii underscore letters to the variable named ABC. We will of course print it right below, just so we have a nice idea of what we're dealing with. And we get a very long string that consists of all the lowercase and all the uppercase letters of the English alphabet, which is great for words. But messages sometimes contain dots and commas or other punctuation symbols, so let's tackle it as well. We will simply concatenate string.punctuation to our alphabet, and if we're already here, we might as well tackle digits too, so string.digits. And since messages sometimes consist of several words, we will also need a space character at the very end. Now let's save everything, let's make sure we didn't mess it up. And beautiful, we are now dealing with a much longer string. Cool, so back in our code, we now need to find a way of selecting characters of interest. So one way we can do this is using the find method. So we will simply add .find after our alphabet, and let's say that we're looking for lowercase c. Okay, so this brings us to the number 2. So what exactly is 2? Well, if the index of A is 0, the index of B is 1, then the index of C is 2. So great. This means that the find method returns the index value of the character of interest. Now, we're not interested in this index, we're interested in the next index, in the shifted one. So we'll simply add 1 and boom, we got it. Now, since we're not looking for the index itself, we're looking for the character, we will encapsulate this expression within a set of square brackets, and we will then pass it as the index of our alphabet. Ha! Now let's make sure this returns D. Before we move on, and beautiful, we are indeed getting D. So we are selecting C, but we are getting D. Awesome! So this means that the majority of our algorithm is written here. The next thing we'll need to do is we will need to copy our encrypted message local variable from the encrypt function. We will paste it right below our alphabet, and we will change the parameter of message to self.myMessage. Next, we will also replace the string index instance of index with the expression within our print statement. We'll just copy it and we will replace it within our list comprehension. Now, the last thing to tackle here is instead of hard coding C, we will pass the iteration variable of char, which represents each of our characters one at a time. And then instead of printing our ABC, our alphabet, we will print the encrypted message. And only now we can move on with the assertion. So in the case of evaluating whether two things are the same, we will simply use self.assert equal. Now the first thing we will pass here would be the local variable of encrypted message. And right next to it, we will pass the output of encrypt. Cool. Now let's save everything. Let's give it a run. And haha, we are failing our test. Let's have a look why. Yeah, because 0, 1, 2, 3, 4, 5 is not Sibobob, which is the Caesars Cipher equivalent of banana. Okay, well, that kind of makes sense because we have edited our test, but we haven't changed the production code. So let's go ahead and copy the alphabet as well as the encrypted message variable. We will scroll all the way up and we will replace the body of our encrypt function with what we just copied. Then we will backtrack from self my message to the parameter of message. And we will of course fix the indentation. If we now save this code, we'll give it a run. We are passing all our tests. So folks, in the moment of truth, everything works as expected. Banana is indeed Sibobob. But what happens if we pass some different string? What if we use a different input? For example, banana bread. Do you think it's still gonna work? Well, there's one way to find out. Let's run it. And surprise, surprise, it doesn't work. We get an error here. So what's going on? We see that the string index is out of range. Let's have a look at our code. Let's also enlarge it. Forgot to enlarge it the last time. Now, what we have here is all rainbows and butterflies as long as we're not dealing with the last character of the ABC string. Because once we reach the last character and we add 1 to the mix, we are fetching an index value that doesn't exist. So we are okay with the shifted version of the character only if the length of our ABC alphabet is greater than the index we are trying to fetch. Okay, we'll just copy it. We will place it within a set of round brackets, just so we can visually separate it from the rest of our list comprehension. And if it is not the case, we will need an else clause where we will simply pass ABC in the index of 0. So in other words, the else clause is only here for the space character because this would be the last character of our ABC string, right? There you go. Okay? Hopefully it fixed it. Now, since we've done it inside our production code, we will also need to apply it within our test. We'll just copy it, okay? And we will make sure we are including it in this list comprehension below. Beautiful. Let's save it. Let's give it another run. And now it's the actual moment of truth. Ha! We are indeed passing the test and our space character was replaced with a lowercase a. Great. Now, let's test our punctuation symbols and digits. Let's see how it works. So what if we pass here, I am Batman, and then 888, right? Let's see how it looks like. This is the ultimate input we should test. And beautiful, 888 turned to 999, exclamation symbols turned to quotes, and I am Batman turned to Jabna Kbunbo. Jabna Kbunbo, folks. Jabna Kbunbo. And here's a challenge. Can you adjust my code in such a way that instead of shifting the alphabet only one place at a time, we can select a different shift factor every time we make a call to encrypt? So for example, instead of hard coding +1, can we adjust it to +4? And then the next time to +8, and then -8, and even -100. We call this type of a cipher the Visionaire cipher, and I would love to see your solutions, including all the unit tests you use to get there. Now, you can either share in the comments below a link to your GitHub account, or alternatively, we can do this through Wayscript. We'll just click on the cloning link, which you can always find in the description, and we will click on this log in to clone button, and we will select which platform we'd like to log in with. I'm gonna go with Google. And once we are logged in, we will select the workspace to which we'd like to clone our script. You most likely only have one of them at this point of time. We will then click on clone. And there you go. Now we can see a copy of my list comprehension script within your environment. So let's click it. Let's click on Open Text Editor. Let's open my list comprehension.py file, and yeah, it looks pretty familiar. Now let's say we've performed a bunch of changes here. Let's say there's a comment here. This is very different. And once we are ready to publish our script, to share it with the world, we will click on this deploy icon here, and we'll click on deploy, confirming our deployment. Beautiful. Then we will click on this Settings tab where we can find this Publish button. We will, of course, click it. And once we do so, we can then copy this endpoint link. We can paste it in any browser, and this will fetch our very different README and will allow everyone else to clone your script. Now, thank you so much for watching. I really hope you enjoyed my take on unit testing, and if you did, please share this tutorial with the world and don't forget to give it a huge thumbs up. Now, if you'd like to see more videos of this kind, you can always subscribe to my channel and turn on the notification bell. I'll see you very soon in another awesome tutorial. In the meanwhile, bye-bye!